Okay guys, today I'm going to do a little magic trick in that you see I have my ZW-EF here, the electronic focuser, that is connected via a belt to the focuser of this telescope, which is the SQF55. Excellent little telescope, by the way. But I'm going to take the USB cable here and I'm going to remove it. And I'm still going to be able to focus this telescope via autofocus using Nina. And yeah, I want you to guess why that would be. So we have spacers, we have a tilt adapter, we have a camera. Technically, we don't have any autofocuser connected, or electronic focuser connected to the little Gaius S2 computer at the back. So yeah, this is disconnected, and yet we're gonna make it work. This might be a bit of a misdirection there, because if you're thinking it's because it's actually the EF Pro that I have here, and therefore I'm controlling it via Bluetooth. It's not the case. Yeah, so now there's only one thing left that it could possibly be. So yeah, hopefully you've guessed it. But basically, let me show you what it's gonna look like. I mean, first, I do need to point the telescope towards an area with some stars. There's a lot of thin clouds above, so it's really not ideal for this kind of experiment, but you know, I gotta take stars, even if they're covered by clouds, whenever they're available. So I'm just going to go to my imaging tab in Nina. We're going to go to the manual focus targets, select whatever is the highest, Vega. There it is. Smack in the center, Vega. Yes, if you know it's from the movie Contact. Anyway, yeah, let's slew to Vega. Okay, so here we go. This is a 5-second exposure on Vega. You can see it has a halo. It's really because of the thin clouds that we have above. But it is what it is. We can work with that. And I have actually HAO3 filter in there, the SV220. So it's we're going to take some longer exposures for the autofocus. But I still have, by the way, the EF is still disconnected. There is nothing in the USB port, just to be clear. And it's not the EF Pro. So I'm going to go to autofocus and just start autofocus and see what happens. Okay, we've moved the focuser by the initial number of steps. We're taking an exposure. Let's see what the image looks like. Looks like this. We get stars detected. Go back to the autofocus. We don't have a point yet because we need a second one before the chart gets to be updated. We're moving the focuser again to a certain position of 926, which actually in our case stands for 926 microns. And we're taking a second exposure afterwards. Again, we get an image, it's going to get analyzed, we get the stars analyzed on the image, and we are moving the focuser again. It looks like it's working exactly as you would expect if I had the EF plugged in, which again, I have not. So I'll let it be for a little while and then get back to you once we have a complete autofocus curve to see the results. And then of course I'll explain exactly what is happening and how I made it happen. Also about how you can make it happen if you have a certain piece of gear that I have on this imaging train. And the autofocus is complete. This is the beautiful curve that I get. This is a perfect autofocus curve. And you can see we're oscillating in terms of focuser steps between around 280 and 1000 something, with the best focus point at 652 that we have discovered. If, by the way, I look at my autofocus options, the backlash is intentionally set to 0 because that mystery method that I use for focusing self-corrects for backlash. So you don't need to care about that. Okay, so now that we see how it works, let's look at the image that was generated once in focus. Like we are really well in focus. This is a very nice star field. And I'm retaking it as a color image just so that we can see it without all of the annotations. And through the clouds, you can see the stars are tiny. So yeah, we have definitely best focus. Didn't have to bother about backlash. It's just perfect focus very easily without an electronic focuser. I'm gonna get the scope back home so we can look at the imaging train again to see exactly what's happening here. Okay, we have the full imaging train nice and visible in the field of view again. And you guessed it, what I used for the autofocus was not the EF because it's disconnected. It was this red thing here, which is our tilt adjuster. So this is, I made a video about it this very recently. I'll put the link above and down in the description if you're interested. It's a very expensive but automated tilt adjustment module that basically lets you get perfect tilt on your camera with zero effort. It's basically fully automated and it's amazing. But when I published a video, one of the things that I was told in the comments is like, oh yeah, you mentioned it could be used to tune the back focus. What about for autofocus? Especially if you have a design like the telescope here, which is a Petzval design, meaning it doesn't care how far the camera sensor is from the flange of the telescope, as long as focus is reached. Like, what if we use this thing here as a focuser? Move it back and forth and use it as a focuser because it has 1.2 millimeters or 1,200 microns of travel available from its 0 position to 1,200 position. And yeah, I thought that was a great idea, and so I raised it to Wanderer Astro, but that was today, so it's not like they came up with an ASCOM driver for that. I made one. So I spent the last couple of hours making an ASCOM driver for the Wanderer ETA, and that's because the ETA actually, Wanderer very wisely published the serial protocol that they use for the ETA, where it tells you what command you can send the ETA to move each of the pivots. There's 3 basically pivots, and then what commands are hard to read the feedback from the ETA telling us what the position is. And I used both. I also lie to Nina from time to time for technical reasons. I have the source code online. It's horrible. The huge thing is a workaround. I'm also not a developer. I really should have used threads, but it gave me an error and I didn't feel like messing with it. And as I mentioned earlier, for technical reasons, I have to lie to Nina. But otherwise, it works, right? It works pretty well. So just to show you how it looks in Nina itself, if I go to my equipment tab and go to the focuser, you can see I'm using the ASCOM focuser driver for Quiv Wanderer ETA. Yeah, now it's no longer the Wanderer ETA, it is the Quiv Wanderer ETA. And we have the standard stuff, the position, etc., and your target position, which you can change. It acts like a normal focuser. And I've created the ASCOM driver in such a way that as it moves back and forth for the autofocus, like really it goes through all of the points and then goes to the point of best focus, it does it in a way that will protect the tilt adjustment that you have already put. So if your first point is at 400 microns, the second point is 450, and the third point is 475, which lets you, for whatever reason, basically correct for the tilt. As we move the whole imaging tray via the Wanderer Astro ETA back and forth, I keep those deltas. So if I move it 50 steps upwards, like if I increase by 50 steps, we'll keep the exact same differences between each of the pivot points there, so your tilt adjustment is protected, unless you make this go all the way to 1200 or all the way to 0, in which case like the tilt adjustment will just like get crushed against the limit. So you do need to be careful. And because you only have 1.2 millimeters to play with, it's not a lot, right? So if you have a slow telescope, it's not going to work. But if you have like an f4.9 as I have here telescope, it's doable. You can see that if I go to my autofocus settings, I have the autofocus step size to 80, and based on the autofocus chart that we see here, we go from 1 point something to 4. I could probably reduce it to like 50 steps or 60 steps, and it would still work great and give us a good result. So it means that we can really achieve autofocus with the SQA55 within just 1.2 millimeters, or actually even like just 500 microns, 600 microns. So it's pretty cool to see that as well. We have, one step is exactly 1 micron with this thing, and I kind of like that. So how do you get your hands on that? I don't know how to make an ASCOM installer, so it's kind of manual, but I'll put a link to the executable file that you can use to register the ASCOM driver. and then you'll be able to use it in Nina. If anyone knows how to make an installer, I tried, I failed, but if anyone knows how to make an installer based on that exec, let me know. And once you've done it, just send me the installer, and I'll upload it and put the link down in the description. So again, I'll have the source code as well down in the description, as well as the executable file. And the way that it works is if I go to my files there, it's going to be like this executable file, and you want to put it somewhere on your computer. And from there, in the folder, you want to go to right-click, show more options if you have Windows 11. Then you want to open in terminal. For me, it opens a PowerShell, but for you it should be slightly different. And then you're going to type like ASCOM dot quiv, etc. So the file name here. When you have the first letters, you can actually tap on Tab on your keyboard to have it autocomplete to the name of that exec. And then you want to put a space / reg server. Boop. There it is, and that's it. That's all you need. Afterwards, if you restart Nina, it will be available in Nina to connect to, and it's the usual stuff, right? So you go to the equipment tab, to your focuser tab, and you want to make sure to click on the gear icon and select the right COM port here. That would work. If you're not sure, you can open the device manager and go to your COM, to ports, COM and LPT, and you want to find the one that has the CH340 in it. And that's the one you want. So this is COM8, and you can see I have COM8 here. Validate this. I can close this now. Connect, and now you are connected to the focuser. One thing to note is that I can, like from the way that we interface with this ETA, is I can only move one pivot point at a time, and it takes roughly 50 milliseconds to move one step. So if you move a large number of steps, it can take quite a while, but just be patient. It will get there. So there you have it. If you have the ETA and you want to experiment with that, please go ahead. Note that I do not take responsibility for anything that happens to your equipment. This is a best effort thing. I'm not a developer. I don't know how to work with the serial protocol. It's all super not very well done. If you're a developer and you know how to improve my codes, because there's so many ways it can be improved, feel free to send me a pull request or stuff like that, and I'll have a look. And of course, I guess at some point, maybe Wanderer Astro will come up with their own ASCOM driver that's going to be much better built than whatever I came up with in those couple of hours. With that, what do you think of that? Now the Wanderer ETA doubles as a kind of weird-ish autofocuser. That's actually super precise and has no backlash because it self-corrects its own backlash when I send it instructions to move. It's actually kind of cool. So yeah, let me know down in the comments what you think of that. While you're at it, please leave a like. It really helps the channel out. You can subscribe as well, in which case welcome. And if you want to support the channel even more and you're planning on buying anything from Agena, High Point Scientific, etc., such as the Wanderer ETA, if you do so after clicking one of the links that I have down in the description, it will help me out at no cost to you. If you want to become a sponsor of the channel and really make these videos directly possible and you appreciate my work, you can become a Patreon supporter. The link is down in the description. Our channel member, it is the join button next to the subscribe button. And my Patreon supporters, channel members, you know it. You make all of this possible. And thanks to you, we have an ASCOM driver for this to use as a focuser. So awesome. Thank you so much as always. Anyway, with that, thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.